So yeah, let's start. 80 people already in. So hi everyone. Good morning, good afternoon, good evening, good night, maybe if you're also from Australia. So yeah, Noel, please start.
All right. Thanks everyone for joining. So today, the topic I'll be covering is stream processing in SQL with RisingWave. So thanks again to Alexi for organizing data talks. I think, yeah, pretty excited to have a good sharing and a great workshop. Yeah. So a little bit about myself. I'm currently a database kernel engineer at RisingWave, and we are building a cost-effective and scalable database solution, which is designed to streamline data processing and query serving. At RisingWave, my focus is mainly on performance and reliability. So for example, some fuzzing tool I have built would be SQL Smith, so that does fuzzing for RisingWave, and backfill, which is like a feature used by our materialized views. So previously I studied at NUS and my focus area is in programming languages. Yep. So this is the rough overview of the workshop today. So I'll start off with talking about, why use stream processing, what exactly is RisingWave, and then after that, I'll go into more detail about how you can use RisingWave, how you can ingest data into RisingWave, deliver data from RisingWave to downstream systems, talking about stateless and stateful streaming computation, and then finally, I will move on to the hands-on project where you all will be able to follow on. Yeah. Okay, yeah, so let's get started. So with regards to why use stream processing, I will do a comparison between batch and stream because I think batch processing is what most people are familiar with. And yeah, stream processing might be still a relatively new um, concept. Yeah. So for batch data, in terms of the data being ingested, the data is coming in hourly, daily, weekly batches. So usually the data tend to be more static, and the the data load is lower as well. On the other hand, for stream processing, the data coming into your stream processing system tends to be dynamic, high volume, high velocity, and they can come from things like IoT sensors, feeds, databases, and your stream processing system needs to be able to handle these events. So specifically the ingestion part. Yeah.
If I may
And so
add,
now that
sorry for interrupting, just for the context for course participants. So we previously mostly covered batch. So the workflow orchestrator module, when we talked about Mage, it's mostly, at least we used Mage as a batch processor. Then we talked about DBT. So it also processes data in batches. And then Spark also, we talked about Spark batches, not Spark streaming. So in Spark, the module we covered about Spark is also batch processing.
yeah. So with regards to the way we process data, so now that the data has been ingested from some upstream source, for batch, I think most people are familiar. Your events will get ingested into your batch database. And oh yeah, someone asked in the chat if they can. Let me just get all the links up.
But please send it to me. You will not be able to share it in live chat. Send it to me and then I'll post it there because there is some anti-spam filter.
Sure, sounds good. Give me a second.
Here in chat. And then Ella added that it's in the repo, so probably the repository contains it contains the slides, right? Let me check.
Seems like I didn't upload it just yet.
But in any case, so what I'm going to do right now is I will share the link to our workshop page, and then the workshop page has a link to the the other repo. I will
Okay,
show it
sure.
to you. And then
Yeah,
that
I will send
one,
the slides again after the workshop as well, for those who want to reference it. Yeah.
and then
Okay,
yes, somebody
so
said that there is indeed a PDF file.
okay, great. Let me should find it. Oh, it's there. It was hidden. Okay. Yeah, this might not be the latest. Yeah, data talks. Let me just send it in the Slack channel. Okay. You should see it. It's in the data engineering Slack channel. All good? Okay, continuing. So for batch, yeah, so for your batch engine, your events are going to the database. And then your application here is going to run your batch queries every time. It needs to extract some information from the database. For example, here you have a join query, where we join 3 different tables, and we, fetch the data from those 3 tables. And here, basically, if we have like 1 million records, we'll run the batch processing pipeline each time we run that query. So examples will be things like Postgres and ClickHouse. Yep. On the other hand, for stream engine, like RisingWave, for example, we run things in incremental fashion. So similarly here, we have 3 sources of information. So A, B, and C, right? So when the events come in, actually, they get streamed into our pipeline. And basically what happens is that each of these nodes here, what they would do is that they'll calculate the delta. So basically a change in the state and change in the stream, right? And you'll propagate that. And as events come in, as records come in, these records will get processed and we'll just emit the changes incrementally into our application. So the kind of latencies we can expect is much lower. So later on, actually, I have some examples which would show you like how this exactly works on on some sample data. Yeah. So just to recap and give some examples, how would you analyze social media data for sentiment analysis? And how would you monitor the performance of a fleet of IoT devices? So for for the first one, you can use either batch on stream, depending on your use case. So for example, if you wanted to do sort of real-time sentiment analysis and do like trading on it, right? But you want your analysis to be real-time. Generally, you would want a streaming engine that can give you lower latencies. Whereas if you are talking about something like analyzing a week's worth of data to derive the sentiment from there, you can use a batch engine and you can run more complex queries from there. And for the second one, I think you would generally, again, use a stream engine because, on a fleet of IoT devices, usually you would want to get this real-time monitoring and alerting from that. So yeah, you will want something that can give you that low latency. Okay, so now we're done with the first part. And now I'll move on to introduce, what is RisingWave. So here is actually an architecture of RisingWave. So it's actually like a distributed system where we have several key components. So we have 4 key components. The first one where the user actually connects to the database, that would be through the front end. So you notice that the user can just use PSQL. So people who are familiar with Postgres, you can just use the same tools you are familiar with. Because RisingWave is mostly PGWire compatible. Yeah. And so the front end will take care of parsing, validation, optimizing, and later on it would generate a query plan, which it would then pass to the compute node. So the compute node would then, run the query and regularly feed the results back to the front end. And for the compute node, so apart from executing these plans, it would also take care of things like data ingestion and not shown here, but data delivery as well. And then, it would use this object storage as the persistent layer. So because we use the LSM tree for our storage, we need to regularly run compaction, and that's what the compactor is for. And for the final piece of the puzzle, we have the meta server. So it's in charge of taking care of the metadata from the entire cluster. So the key thing to highlight is that the meta server here is responsible for scheduling and monitoring stream jobs. Yep. So continuing on, so these are some of the characteristics of a stream processing engine. So the processing model would be, for RisingWave, it can do both batch and stream, but the key thing is that it must be able to do stream processing. And then for latency is low, seconds to milliseconds. Throughput is high. Fault tolerance, it has exactly one semantics with checkpoints and snapshots. What this means is that, if you encounter your cluster nodes crashing, right, and the cluster gets recovered, the data that it processes, won't be reprocessed, so you shouldn't get duplicate data. And yeah, you also should, because RisingWave actually does very frequent checkpoints, you should be able to recover relatively quickly as well. And yeah, so for API support, is SQL only for RisingWave, but we also support things like UDFs, so user-defined functions. And that means you can code in other languages like Python, Java, if SQL is not sufficiently expressive. And for the storage system, we use something that's integrated. So we build our own internal storage system, which is based on, it's called a Hammock state store. So it's based on Hammock tiered storage. Yep. And for the final part, for state management, again, this you would see in a concrete example later. We support stateful queries when we do the incremental view maintenance. And yeah, use materialized views to process our incoming data. Yeah. So now comes the more detailed parts about how you actually can use RisingWave. So for the data ingestion and delivery, here are some examples of upstream sources. It is not exhaustive. You can actually check our documentations if you want to view the full list of source you can ingest from. And then data delivery, you also have different things you can sync out to. So this provides even more functionality. We tightly integrate with the entire data ecosystem, so you can sync out to other parts of it if you want to do more functionality. Yep. So for the workshop, we actually use Kafka and ClickHouse as the upstream and downstream systems. Yep. And later on, you will get to try it. Yeah, so now we'll move on to the computation itself. So here I'm providing an example. So here you have a create table DDL, and then you also have a create materialized view, which is created on top of that table. And what it does is very simple. It just selects and filters values which are greater than 0 and adds 1 to them. So later on you'll see that there's no state, which is why it's called a stateless computation. So this is a query plan, which you can just get by, prefixing an explain in front of the materialized view. And just very briefly, what it does here is that, as mentioned, it scans these columns from the table, and then it does the filtering, and then it does the addition as well in the project, and finally it materializes it. So this is a materialized view. So you incrementally update the state of it. Yeah. So to avoid confusion, actually, I've highlighted the parts which are doing the processing here. So materialize, of course, is going to be stateful, right? Because we got to materialize the results. We got to store them, right? But the intermediate processes, intermediate steps, they are actually stateless. Yeah. So let's use this as an example. So for example, you just run some DML to insert 2 records in, 0 and 1. And I'm just including these definitions here so that you can follow along. So these deltas go into your system. So insertion is basically you're adding the change is you're adding a new record, right? So yeah, that's the operation. And then you're adding a 0, adding a 1, so that continues on. So after you scan it from the upstream table, you'll feed it again from scan downstream to filter. Now that gets filtered out because you can see that here, this first record is not greater than 0 clearly. So you get 1. And after that, you add another 1 to that record, and you get 2. And this will just get materialized. So yep. Another example here where we have a delete from the upstream table. So instead of the addition you saw earlier, it would be a subtraction, or you are basically removing these records, right? So that's the delta, that's the change. So again, that gets passed to filter, and then we filter out the 0, and then we add the 1 to that record, and finally we materialize it. So inside materialize, you would see that the delta should be removing this record here, 2, and you would do that accordingly. So now your table have no records. Your materialized view will have no records. Yeah. And so now moving on to stateful computation. So I'll start off with something simple, aggregations, and later on I'll move on to something more complicated, which will be joins. So again here, we have the table that we are creating, and what we are doing is just a count of all the records in that table. So it's very straightforward. And what we are doing here is that we are running a scan on that table, and then given these records here, we feed it down to the aggregation. And suppose that the original state of the aggregation is 0. After we receive these deltas here, because there are 2 records, we will just update the count to 2. And then we need to propagate the changes, right? Because the previous count was 0, correct? So we need to remove that because the count is no longer 0. We need to change that to 2. So we remove that, add 2. And then we tell materialize, these are the changes required. Materialize does that, and yeah. And yeah, so for the final one, we have joins. Yep. So for joins, here we have 2 tables, T and T2. And what we are doing is just joining on the V1 column of these tables here. And then after that, we just select columns from both tables. So consider if we have this set of records coming in, where V1 is 0 and 1, and then we feed that and continue on. So what happens here is that the hash join here is stateful. So it contains 2 states, one for the left-hand side table, the other for the right-hand side table. So what happens when hash join receives this set of records? It will update the state. So you can see here that the left-hand side table accordingly, because we are scanning from the left-hand side table, we are updating the left-hand side of the hash join. And then what it does is that, it checks against the right-hand side of the hash join. And it sees that, there are no matches. There's basically no records in the RHS at this point. So there's no records going to be emitted to materialize. There are no deltas going to be emitted to materialize. So now consider that, some records come in from the right-hand side. So we have V1 and V2, where, we have, 1 and 2, values 1 and 2 coming in from V1. And we update the state again. And then we check. And we realize that there's a match on the join predicate. So remember here is that what we are doing is to check if T.V1 is equals to T2.V1. Then you can see there's a match. So T2 here is on the right-hand side, right? And you can see that, it matches with this. So here, we will admit that, there's a change. And of course, we feed the values in as well, the selected values in. So here, we selected V2 from both sides. So yeah. Yeah, so that gets propagated to the materialize, and yeah, materialize will be will insert this record. Yeah. And with that, we are done. So now we'll move on to the hands-on project. And let me just change my screen. Yeah. Okay. Let me share some links to the workshop itself.
That's the one that you linked in the workshop page, right?
Yeah, exactly.
So I already put it in the
Yeah.
description of the video. So if you go
Okay.
down, if you go below the video, you'll find it. So it's
Okay,
RisingWave
great.
Labs / RisingWave Data Talks Workshop 2024-0304, right?
Yep. Okay, awesome.
Yeah,
Okay.
so I put it in
Then
the
with that
description. Just click on that.
we can start. Let me just share my screen. Share. Okay. Be able to see my screen? Okay, great. So, yep. So this is the workshop page. You can clone the repository if you want to follow along. And yeah, so basically here, we will use RisingWave. And the prerequisites are listed in the workshop page. You have to have Docker and Docker Compose, Python, PSQL, yep. And then with that, yeah, you can get started by just running this set of commands here. And I think I will give everybody some time. You can also take a break in the meantime, maybe like 5 minutes to set this up. Yeah, in case there's some people who want to follow along.
Yeah, I'm just thinking if this is the best idea, because like what we used in the course in the first
Yeah.
module was not PSQL. We used PGSLI, which is a different tool. I don't know how different it is.
Okay.
So we just used Postgres from Docker. Not like we didn't install Postgres. At least we did not ask students to install Postgres on their machine locally, only from Docker.
I see. Okay.
So it might take some time to actually install all the prerequisites. And the question is like if 5 minutes is sufficient, I think it might take more time. So I wouldn't spend time right now. Maybe we
Okay, sure.
just
Then
continue and
let's just get
then we can
started.
take it in, yeah, we can answer questions later in async mode.
Okay, so yep. Let me just briefly share about the Docker Compose file. So okay, yeah. So this is sorry, let me just say about the structure of the program first. So the structure of the project is that, there's just Kafka, RisingWave, and ClickHouse. So it's a very simple system. And we are using RisingWave's Docker Compose file. And what we do is actually we just modify it slightly. So if you open up the Docker Compose file, you can see that we just added ClickHouse as well, so that we can use it as the downstream system. And yeah, you can just like scroll through this if you ever want to set up RisingWave with different components. Yeah. So the first thing that we'll do is actually to ingest data into RisingWave using Kafka. And yeah, there are some reference docs here if you want to take a look later on. And the main file that you would be looking at would be the seed kafka.py file. So this actually contains the logic to process data and populate RisingWave. So, oh yeah, before I continue, I think I should briefly mention what data sets we are using. So we are using the following data. So it's actually included already in this repository. So if you cloned it, actually you should have the data already. So we'll be using this text yellow trip data 2022 on January and the taxi zones. So actually, yeah, you can actually open that up and take a look to see what that looks like. Not this one because this contains a lot of data. So what we'll do actually during this workshop is that we'll replace the timestamp fields inside this trip data file with timestamps close to the current time. So that's already done by this script here. But that's done because, this strip data file contains historical data from 2022. And, when we are working with a stream processing data, generally you want to process something like real time, right? So, yeah. And yeah, so, we can start the stream. So it's pretty straightforward here. What we do is that, we want to first load the taxi zone data. So this is like the dimension table containing all of the different details of the taxi zones, like their names, for example, and the IDs. And yeah, so inside seed kafka.py, if we open that up, you can scroll to the main function here. It's pretty straightforward. We just get the file path, send the records inside to RisingWave. Yep. Create this and send off the records inside. And then the next thing that we do is we'll process strip data and insert it into RisingWave. So we just ingest that via Kafka. So you can see here that send records to Kafka basically uses the Kafka producer. And yeah, it just sends the data into RisingWave from Kafka. So this is the data ingestion part. Yeah. So if you're curious about the kind of libraries we are using to ingest into RisingWave, this library is the one we use for the client side, like just running like the DML, DDL, and so on. And we use Confluent Kafka for connecting to Kafka from Python. Yep.
You went a bit
And
fast over the details. So I just want to make sure I understood what's happening. So
yep.
So what we want to do is we have a Docker Compose file with RisingWave. We have there inside this Docker Compose, we have Postgres, right? No, we don't have Postgres. So we have
No, we don't have Postgres. RisingWave
so
is running.
Postgres is only for connecting to RisingWave, right?
Yeah, correct.
Postgres interface, right? So what we have inside the Docker Compose file is Kafka and ClickHouse, right? So when we
Yeah, you
do
can see
Docker
the whole
Compose up,
list of things here
yeah, so
actually, of
you
what is
went a
exactly
bit
inside.
fast over that, so I at least didn't have a chance to actually see what's there. So we have ClickHouse there, we have Kafka there, and we have RisingWave, right? So
Yes.
we do Docker Compose up, all these things start, right?
Yeah.
And then what we do next is we run this send kafka.py file, which reads from these two files that we talked about, zones and yellow taxi trips, right? And what
Yes.
it does, it reads the taxi trips file and one by one sends them to the Kafka topic, Kafka stream, right?
Yes, correct.
And
That's
then
correct.
internally, RisingWave is configured to read from that stream.
Yes,
So
correct.
it
Yeah.
consumes from Kafka
Yes.
and then
So I'll
using
be
the
going over that later actually.
okay.
Yeah. Yeah, but
But
that's great,
do you
great.
already have Docker Compose up running, like all these
Yeah,
things
I'm
running?
going to run it right now. So
Okay.
yeah. So before you run, I think inside the README file, inside the getting started part, it would guide you on how to, get your cluster up and running. So you can just run those commands.
So the situation we're modeling here is that, let's say we work at this taxi company, right? And we want to build a dashboard, a real-time dashboard. So for that,
Yeah.
each time a trip completes, we receive an event through a Kafka topic, through a Kafka stream, right? So each time like a customer leaves a taxi, then an event is generated, which is sent to the stream.
Yes.
And then what we want to do is we want to do some real-time analytics. This is the use case we are after, right?
Yeah, that's correct. So in this workshop, we actually don't sync to Kafka, but it's possible to do so. Yeah. But we do have a dashboard. Yeah. Can take a look later. Yeah. So we'll start cluster. Okay, great. So now the cluster has
And
started.
start
Yeah, you can take a
cluster
look
is
and see.
what exactly is it doing?
So you can actually open the commands.sh file. These are just some short aliases that you can use. So start cluster basically just does Docker Compose up.
Okay.
Yeah, and then yeah, it's pretty straightforward.
So it starts the Docker Compose file you showed us, right?
Yes, correct. Exactly that. Yeah. And yeah, so continuing on, Yeah, I think I already have ran this already. So I'm inside the Python virtual environment. And yeah, let's start the Kafka stream.
So right now we're using this Confluent client for sending the records, the rows from the Parquet file to our Kafka topic, right?
Yeah, that's correct.
And yeah, it's a
So
send.
Kafka is getting populated. Yeah. So yeah, and then now that there are records going into Kafka, we actually need to run create the corresponding table in RisingWave to fetch that data or the source from RisingWave. So we can look at the definition for that. It's a pretty simple one. So you can see that what we do here is we just fetch all of the fields from Kafka. Kafka, we have a source that can decode Kafka records encoded in JSON format, and we just specify it's a Kafka connector, specify the Kafka topic, specify the servers, the server through which we will reach Kafka. And what we do here is straightforward. Now we'll just run that file, right? So you can see, as mentioned here, just run that. So SQL/table.
From what I understood, since it uses Postgres compatible interface, we can use any tool that can connect to Postgres, right?
Yeah,
For
that's correct.
interacting. So which means
Yeah.
that the tool we used, PGCLI from the first module, should also work with RisingWave, right?
Well, I didn't try it out personally, but yeah, give it a shot. Maybe I think it should work. Yeah.
But I think like since RisingWave follows the same interface, theoretically it should work, right? Because also in your example, in the Python code, you use this psycho-PG thing for connecting to
Oh yeah.
RisingWave, right?
Yeah. Usually, I think most should work. Yeah.
And
Okay.
PGCLI uses this psycho-PG.
And so now we'll just run show tables. So here you should see two tables to make sure that yeah, both are created. And yeah, okay. So now we actually start validating the ingested data. So we can just select star from XC zone. And yeah, you can see that there should be around like 265 records. Just widen it a bit. Yeah. So yeah, you can take a look and see what it looks like. And we will also query for recent data. So let me just copy that. And what this does is basically selects a bunch of fields from trip data. Show table. So recall that we have trip data. So what it does is that it selects just some records, some columns from it, because it is a rather wide table. So we don't want to select everything. And what we are doing here is basically just checking the drop-off time. And we want to say that the drop-off time here should be at least 1 minute before the current time. Yeah. So this will fetch recent data 1 minute before current time. Yeah, so you can see the pickup time. These are all in, I think, UTC. So yeah, but yeah, you can look at the drop-off times. Should be all relatively recent. Okay, yeah. So continuing on, we'll do some simple joins to get the names of the zones. So here what we do is that you can see that we are running the same query from previously. All we are doing is that we are joining on certain columns of the taxi zone, specifically the pickup zone ID and the drop-off zone ID. And the reason why we are doing that is because we want to actually get the taxi zone names. So this is actually a field corresponding to the taxi zone names. right? So let's run that. And you can see here that, okay, let me widen that a bit more. Yeah, you can see here that, yeah, you can get the names as well of the pickup and drop off zones, and they should be relatively close to the current time as well. Yep. So we actually show that, RisingWave can run some batch queries, and yeah, it's pretty straightforward to do so. Finally, we'll just create a materialized view from that. So all we need to do is to prefix this line here. So create materialized view latest 1 min trip data as, and then just add the batch query there, and we just run that. And so yeah, now we have the materialized view created, and we can just regularly query that for the latest data. Yep. So /watch. Yeah. Okay, it's rather long. Let me just limit that. So limit. Okay. Yeah. So you can see the latest data coming in. Yeah. Okay, yeah. So you should have followed, if you have followed along, yeah, there should be, demonstrating the basic capabilities of RisingWave. And what we'll do now is to actually start processing data with materialized views to provide analysis of the data stream. So the first materialized view we'll be creating would be computing total airport pickups. So this is rather simple, right? We just need to filter the pickup location ID to the airport IDs. And let's just recall that, taxi zone contains some metadata around taxi zones. So we can use that to figure out the airport zones. So you can see the zone here should give you the name of the zone itself, right? And if we look through the taxi zones, right, there should be some names which are basically airports. Yeah. So loosely, we can use this to check for airports. Of course, in like production use case, you would probably want to check against location IDs. But yeah, to keep things simple, because it's just a demonstration, we will just use this to filter for airport zones. Yeah. So let's use a join to fetch like all of the records, for the trip data, which correspond to an airport zone. Yep. So you can see that, okay, again, there's a lot of records coming in, and we don't need all of that. We don't need all of those columns, right? It's too many columns. So we can just clean it up a bit and use this instead. So here what we do is, is actually the same as the previous query. All we do is we just do a count aggregation, because what we want here is to get total airport pickups, right? So that's just counting all of the trips. And again, it's like we are just checking whether they are from the airport. And we just want to group the count for each trip by the airport zone. Yep. So yeah, with that, you should be able to see the trips. And now we can again create a materialized view for that. So let's just run that. Yeah. And then you can again query the MV. And you can watch it to see if the real-time changes to it. Okay, you might want to run a sort. Yeah, so yeah. So actually here what we can do is we can examine the query plan to see what exactly is happening for this. So if we look at the query plan, it looks rather complex at first glance, but no worries. I'll annotate it, and then I'll also give a simplified version. So here, what we are doing is we are scanning from the taxi zone. So, we are joining on taxi zone and trip data. So we need to scan from taxi zone. And then we check for taxi zone names, which are, which have airport inside their name. So that's here. And then after that, we just select the relevant columns which we are interested in from the taxi zone table, and we propagate that to the hash join, right? And then after that, on the other side of the join, so we've taken care of taxi zone. So there's trip data, right? So there's the other side of the join. So we scan from there, and then we pass that into hash join. And then from there, the hash join basically just joins on the predicate, So pickup location ID equals to location ID. Yep. And then that gets passed to hash aggregation with a group key. So we are just grouping by the taxi zone, right? And the aggregations here are just count aggregations. And then we just select the expressions that we are interested in. Yeah. So here's actually a simplified version. Let me open up the RisingWave dashboard. So actually you can use that when you're running materialized views. So I'm going to switch
I
my
have a
screen share.
question.
Yes.
So, like, we don't really cover this explain operator in the
Yeah.
course. So maybe you can tell us, why do we actually need to care about that? Like, why do we want to
Okay, sure.
know what's like how exactly it's executed and how do we make sense of all these things?
Yeah. So I think it's like it's helpful to understand it because sometimes the syntax might be a bit ambiguous. You're not sure like what's the evaluation order. So one example would be like join ordering, for example, right? And then you want to make sure that you have like multiple joins nested. So you want to make sure that the order is optimal. Like you join the tables with like less records, for example, first. Yeah. So that's one example. And yeah, it also gives you like some intuition on like how your data is being processed. Yeah, I mean, yeah. So that's why I use the query plan for. Besides that, we also use it for like understanding like where's the bottleneck in our system. So if I show you the dashboard, give me a second. Okay, share.
So maybe like I just realized that in the Spark module, we talked about the query plan or execution plan. So this is similar, like when we have a SQL query internally, what actually happens, it's broken down is in a series of different steps, exactly like in Spark, in order to arrive at the final table that we have, like that Postgres gives us or RisingWave gives us. And
Yeah,
this is what we see here in RisingWave, right?
yeah. And sometimes, I mean, so like it's a lot of times it's used for like optimization. Like for example, you can switch different nodes to use more, I guess, optimal, optimal, optimal plan. I guess you can change out the nodes. You can set certain like session variables to change the behavior. So you can use that to optimize. Yeah. Um, so yeah, you can see oops, this is not the zone we're looking about. So total airport pickups. Yeah. So this is the fragment graph, which basically is the query plan, right? Shown in the graph form. So you can see, like, I'm just showing this briefly because yeah, there's a lot more things going on, like merge batch, that I think is more of a detail that most people will need to know. Yeah, so I have provided a simplified version, but you can always use the dashboard. So you can just go to this link here and use that to take a look at what it looks like in the graph form in terms of how you execute. Yeah, and then in terms of the bottleneck parts, yeah, I'm talking about this. So this is actually just a recent feature that we added to check for the bottlenecks in our stream graph. Yeah. Okay, so now I'll move back to the workshop document. Okay, great. Yeah, so you can again reference this. So comparing this, to the SQL query from earlier, you can see that we scan the records from taxi zone. So this fragment here is in charge of that. scans, filters, and projects. And then the other one is for the trip data, and then it joins on the location ID, and finally does the aggregation. Yep. So you can use that to recap if you're not sure about the semantics of your SQL query. Yep. So moving on to the second materialized view, we actually build off the current one just to make our knowledge more concrete. Yeah, so you can notice here that we are just looking for airport pickups from JFK Airport, and we have added another constraint, 1 hour before the latest pickup. So we can just stop the watch and we can run that. So how does that work? Well, we just change, the like airport where clause into check, for the taxi zone to be at JFK Airport. And yeah, we don't add in the second part yet. So we keep things simple. We just create one materialized views. Okay. And now we talk about the second part, right? 1 hour before the latest pickup. So we also need some way to track that, because that latest pickup is something that's always changing, right? Yeah, because the current time always changes, and the latest pickup as data comes in always changes as well. So we run that query here. So what this does is, it just takes the maximum pickup time. So that's basically the latest pickup time, right? And yeah, we do what we do earlier, which is to widen the table by joining on the taxi zone dimension table, and yeah, add the filter for JFK Airport. And then finally, we want to get the counts from the JFK Airport 1 hour before the latest pickup. So before running this query, actually, I want to highlight something, is that, here we're actually selecting from materialized views. So this is the strength of, RisingWave. So this is one of the strengths where you can build materialized views on top of materialized views, right? So this materialized view here is built on top of two sub-materialized views, right? Airport pickup and JFK pickup, right? So how does this query exactly work? Well, what we do here is simple. We first joined the airport on the airport pickups from JFK Airport on the latest JFK airport pickup, and we just filter, right, according to our conditions stated here. 1 hour before the latest pickup, right? So the latest pickup minus 1 hour. So yeah, pretty straightforward. And then we further just join on the dimension table taxi zone to widen it and provide us the taxi zone names, right? So again, we can /watch, we can select star from JFK pickups 1 hour before, right? Shit. Yeah, so we can see how the count changes. Yeah. Again, I've provided a simplified query plan for that, so you can take a look. This one is a bit more involved than the one earlier. You can see here there's many different parts. So there's the scan from JFK Airport's taxi zone metadata. So this is I think is from taxi zone. Yeah, it should be from taxi zone. And then we are scanning the records for JFK Airport. So this is from airport pickup. And we are finally scanning a dynamic filter, latest pickup time, which is this. So let me elaborate a bit more. So, for like normal batch system, your filter conditions, they are mostly like, sorry, not a batch system, but in a stream system, right? When your join condition, right, is dynamic, that can lead to complications, right? So we use something specialized known as a dynamic filter, which can allow the predicate to continually change. And yeah, so this is known as a dynamic filter. So that's all it is. It's very simple, this concept. It's just that, this data's pickup time can always change. So it's dynamic, right? And we use that to filter the trip data. Yeah. And from that, it gets propagated to stateless simple aggregation and then simple aggregation. So this is basically the aggregating part, right? The count star here. This part here is just optimization to make the aggregation faster. And yeah, we finally project and materialize it. Yeah. So
Continue. So what Murat wrote, that I don't really understand anything. So, and I think he's not alone, because we
okay.
talk about some advanced things here, which we also don't cover in the course, like these operators, like hash joins. And so for many people, it might sound like alien language. And maybe if you're one of those, it's okay. So you shouldn't worry. And maybe, so I think in the introduction, we also kind of talked about that.
Yeah.
So correct me if
The
I'm wrong.
slides actually contain some of the diagrams to show hash join if you,
Yeah.
yeah.
But I guess maybe I'm wrong, but this is not really the most important thing of the workshop. So what is really
Mhm.
important in the workshop, and this is what at the end, if you walk away with knowing that is good, is how you actually run the SQL queries on top of
Yeah.
RisingWave. And also understand that these queries, when you run them, the results actually, you're not running them against a Postgres database. You're running them actually against a stream, right? So the data is coming in all the time, right? And like every time you run a query, you get like new data. So this is slightly different, even though we still use the same interface as we use for querying Postgres, but here, like underlying data model is a little bit different, right? So we have, instead of a database like in Postgres, we have a stream, right? And I think this is the main thing. And the main
Yeah.
idea here is that actually we can use SQL to query streaming data, right?
Yes. Query and process as well. So that's very helpful. Thanks, Alexei. Yeah.
The data is coming in, and the data volume can be huge, yet we can still use the same instruments, the same tools as from module one to actually process and analyze this data. We already know, like in module one, we learned how to communicate with Postgres, like all the SQL stuff, right? And we can still use the same tools, the same things we already know to query data that is inside a stream, right? And the examples we see here, like all these queries, are actually examples of how you can do that.
Yeah. Exactly.
So this is so I guess the important thing here is like you can go through these snippets of SQL code. So like once first you run the Docker Compose up, and then you connect to RisingWave, and then you execute these SQL queries, and then you try to understand what's happening. I guess this would be the most important thing from this workshop, right?
Yes, correct.
Not
Yeah.
understanding the query plans, but like just at least executing these queries and then seeing what happens.
Yeah, exactly that. Yeah. So yeah, so actually building off what Alexei mentioned. So actually, this query here, this materialized view here is being updated real time, right? So that's why when we just select records from it, right? You can see that this number changes, right? We pull every 2 seconds, but we can pull in with lower latencies as well, and we can see, how this would change over time, right? We're just doing a select star from it, right? So this is actually getting updated as records coming from our stream, right? So data is being streamed in from Kafka, going into trip data, and then it just gets propagated through all of these different materialized views and giving us our results in real time. Yeah.
And maybe before we continue, like, can you tell
Mhm.
us why do we even care about this materialized views? Like, why can't we just write plain SQL?
Yeah. So like actually you are still writing SQL, but instead of that, like I think the question you're asking is why run it in like a stream engine instead of Postgres? Is that what you're
Like,
getting
why
at?
why do we create materialized views? Like, can't we just write in one big
Oh,
SQL?
why we can't just write this, right? Why we can't just run the batch query itself? Is that
Yeah,
what
yeah.
you're asking? Yeah.
So we created
So for
two, then we created another one, then we created the third one on top of the first two.
yeah.
Like, what's the point?
So the reason like why you create materialized views is to take advantage of like this stream processing here, right? So when you just run this query, what actually happens is that you run the computation against all of the inputs yeah, at that point in time, right? So whatever inputs you get, you just run the entire computation again and again. So let's say, you have 1 million records, and then you have maybe a table with 1,000 records, right? Each time you perform a join, for example, your query performs a join between these 1 million records and 1,000 records, you would run that join again every time you run that query, right? And that can be very, very expensive. So it'll be high cost, and the low latency will also be high, right? And you want to avoid that. So let's consider that you have records coming in. You're just updating certain records in this 1 million. Maybe you just change one record, right? You don't want to run the entire batch query again, right? Maybe you just added one record, and if you are doing aggregation, all you need to do is add one to the count, right? So let's say you have 1 million records, you do a count on that, you currently have 1 million records, one new record comes in, now you have 1,000,001 records, right? You don't want to rerun the entire aggregation on those 1 million records. Yeah. So that's
It's quite
wasteful, right?
materialized, right? You pre-compute the results and you put them aside, and next time
Yes.
instead of
Yes.
executing the whole thing from scratch, you query the pre-computed thing, right? But
Yeah,
in
exactly. Yeah.
plain Postgres, this is they use the same thing, right? Inside, like when you create a
Um,
view.
no, they just persist the data, but you have to refresh it.
Okay.
And so refreshing it means you are rerunning the query again. Yeah. So it means you can query the same set of data, but I mean it's still results, right? So you have to rerun the computation, the entire batch computation, if you
Uh-huh.
want to get that.
Here, when we have a bunch of materialized views, so we have like one materialized view, then another one, and then the third one on top of these two, and then a new record comes in, right? And then what you do is you see, okay, which materialized views this record goes to, right? And then you see,
Okay.
okay, like update this, and this, and they kind of trigger this chain reaction, right? And then for us at the end, we still query materialized view, and every time a new record comes in, we like RisingWave recalculates all these views
Yep.
for each. I see.
Yep.
So then instead of
Just
doing like,
computes the delta, the changes, that's all. Yeah.
yeah, so instead of doing 1 million joins, we just do one join for the new record, right? And then incrementally add this to the pre-saved results.
Yeah, correct.
Oh, okay. Nice.
Yeah. Okay, yeah, great questions. Yeah. Okay. So continuing on, yeah. So now it's the third materialized view. So actually here we can see some visualization of it. So yeah, here we are just getting the top 10 busiest zones in 1 minute. And yeah, so we can just write some query to get the counts of the pickups from each zone. Right. So this is just a simple batch query that everybody can sort of understand, I think. And what this does is it just does a count of, yeah, it just does a count, right? And then what we want to do is to add a filter as well. We want to get top 10 busiest zones in the last minute. So we basically just add a where clause and say that, the time has to be, yeah, at least 1 minute before the current time. And yeah, so we will create a materialized view for that. And then now we'll move on and also check this query. So both queries will be running the dashboard later on. So I will just quickly run through this second query as well. So this is also rather simple. We are just also getting top 10, but instead of top 10 busiest zones, what we're getting is the top 10 longest trips for the last 5 minutes. Sorry, we changed that to 1 minute, but yeah. Okay, so can just create that materialized view here. And now what we are going to do is we are going to start the server to just fetch data from RisingWave. Specifically fetch the latest results from these materialized views that we just created. And
The
just
Flask
open that.
file, right? Or
Yeah, so sorry again.
so this is a Flask script, or what
Yeah,
exactly is
correct. Okay.
Flask?
Let me just share my screen. Give me a second. So actually the scripts are pretty simple. Let me just share it. Okay, so server.py. So these are just hacked together to like showcase like what you can do. Of course, this is not production ready, but yeah, you just select from the provide two endpoints, which select from busiest zones, longest trips, and you just select like the current results from there. Yeah,
Basically,
and you
web,
just run it over CyclePG. Yeah.
it's just a web API on top of Postgres, right? Postgres API.
Yeah, exactly. Straightforward. Yeah. And then index.html, which is like just simple client side, provide some simple client side JS, render some tables and some charts. Yeah.
That
So
will
you
be
can see
our dashboard.
yeah, correct. So just share my screen. Yeah, so you can see here that the busiest zones are being updated.
Ah, it looks so nice.
Yeah, so this is getting pulled, I think, in like 100 ms, I think, something like that.
Mhm,
Yeah, you can increase the pull rate also. Yeah,
mhm.
so
So
yeah,
what's
you
happening
can
right
see the
now
table.
is it queries your Flask, which queries RisingWave, and every
Yes,
fraction of a second it updates this chart, right? It displays it.
yes. So what you can do instead, I think you mentioned earlier as well, is you can sync into Kafka and use that to update as well. You maybe use WebSockets or something. You can update your web application, and you can also do this in real time. So yeah, I just use DML queries, to keep it simple. But yeah, you can use any sort of downstream components to do this as well. Yeah.
Mhm. And the query is the most popular districts within the last 10 minutes, right?
So
Ah,
busiest zones in the past 1 minute.
okay, that's
And
why.
this one here is just getting like the longest trip distances. So you can see here the trip distance for the last 1 minute. What's the longest one?
Mm.
9 km and so on and so forth.
Yeah, so
Yeah.
Mohammed is asking, so are you currently simulating that there is a stream of data and we apply the queries on top of it? This is exactly what
Yeah,
we're doing.
exactly. So at the very start, I think you should have started running a stream Kafka, but if not, you can try it later on. So stream Kafka, the command there would basically seed your cluster with like this sort of real-time data. Yeah. And yeah, so okay, let me continue to share my screen again. Okay, yeah. So um, where are we? Workshop. Okay, yeah, great. So we've done the first four materialized views. Now we are just at the last part here. Now what we are doing is we are creating a materialized view, which we want to do some data processing, and then we want to sync this data into some downstream system, right? So this is demonstrating the data delivery part. So after data is being processed in RisingWave, we want to stream this data out into some downstream system. So it can be a OLAP system in this case, where we use ClickHouse, right? So we will just create a simple materialized view here. So here, actually, I want to introduce a new concept known as a tumble window function. So to keep things simple, right? All this function does is that it groups data into intervals as stated by the interval argument here. So basically 1 minute windows, right? So let's see how that looks like. So if you
That's a
just select,
specific to RisingWave, right?
I
If we
think
run,
some other systems have it. Yeah, like for streaming systems is most streaming systems should have something similar. It may not be called the same thing, but yeah,
like
it's
if we
known
execute
as like,
the query in Postgres, it will not work, right?
yeah, I don't think Postgres has Tumble. I need to check. I'm not so sure.
There
Yeah,
are some window functions, right? But
yeah,
what
not
is it?
sure about Tumble.
Like, what's the difference between Tumble and like other window functions?
Sorry, there's quite a few window functions actually, so not sure if I will go because it's like a rabbit hole. But yeah,
Yeah, I missed it when you explained it.
so okay. So if you see here, right, like the windows are all 1 minute as mentioned earlier on, right? All 1 minute intervals from start to end. And what we do is we just get the total writes per minute for those.
Mm.
Yeah.
Basically,
And
the seconds, we only keep the minutes and we do some sort of group by that minute, right? Sort of.
yeah, we group by that. Yeah, so you can see that we group by the windows itself. Yeah. So we do the aggregation and yeah, we group by the windows.
And I see here that it has 0, 0 at the end. So yeah, it does truncate, clips away the seconds.
Mhm.
Okay.
And so we can always get, okay, we can just, okay, yeah. So you can always just query that and see what the data is like. And yeah, so this is pretty straightforward. Like for each window, basically what it does is it just calculates the things that we care about. So we are calculating average fair amount versus number of writes, correct? So average fair amount, number of writes, right? So it just calculates that, and yeah, we are done for the materialized view part. Now we'll use this same materialized view here for syncing data from RisingWave into ClickHouse. So why would you want to do that?
Yeah,
Yeah.
like even before that, like I was wondering, why do we need RisingWave at all? Like, can't we just do all that in plain Postgres, right? Because like you can, instead of sending to Kafka, I can just insert to my Postgres, right? And then do these queries. Like, what's the difference between this? Like, why don't they just use Postgres for that?
For which part? Sorry.
Like here, what we do is we emulate streaming by sending things to a Kafka topic, right? And then we query RisingWave to see, like, because RisingWave is reading from the Kafka stream, right? And we get like all this information is updated so we can see real-time queries results. My question was,
Mhm.
can't just avoid RisingWave altogether by sending data directly to Postgres, doing inserting,
So,
right? And then just doing the same stuff as,
you can, but I mean, then it depends on what you want, right? Like,
like,
so are
what's like,
you talking about
yeah, when Postgres is not enough, when we actually need RisingWave?
when you want lower latency? So like the properties that I think I have a properties table that I showed earlier on. Like you're looking at seconds to milliseconds sort of latencies. Like yeah, basically very low latencies. Or your workload is your the way you process data is such that you would process it very often. Like you realize that you start running batch queries very often, right? And on a lot of data, right?
Mhm.
Like in those cases where you're rerunning a lot of computation each time, right? And you realize that, you can save a lot of costs by just doing the incremental computation instead. That's, when you can use a streaming system. Yeah.
See, so what you're saying is when we just do what I said, like if we just use plain Postgres for all of that, it would be a batch system, right? It would
Yeah,
recompute the entire thing every time we execute. So it will not have this incremental small things.
exactly. Yeah.
time new data point arrives, it will not do these small incremental updates, but we will need to recalculate the whole thing. And
Yeah.
here, RisingWave, actually, like we talked about that, like a new record triggers the sequence of updates for all materialized views. So the updates happen quickly, right? So then we're talking
Yeah,
about
correct.
latencies here, right? So if we care,
Latency and throughput as well. Yeah.
right? Okay, I see. Now it makes sense. And now going back to what you were talking about, right? So now, uh, so we say, okay, Postgres is not good for us. We have RisingWave, but now we're getting the data from RisingWave and putting
Yeah.
this to data warehouse. So why?
So it's like you have multiple use cases for your data, right? So maybe on one side you want to do this real-time processing, and one part of your system needs that, like maybe the monitoring or alerting part, right? But let's say you also want to do some like very complex query, but you only need to run it like every hour, that kind of thing, or every week, right? And then you realize that batch computation is suitable for that. OLAP system is what you need, so you can sync to that system. So basically, like use cases where RisingWave is not so suitable for, you would, you can always sync the data out. You're not restricted to RisingWave. You can always sync the data out after you've processed it, and yeah, do further processing in other systems as well. So
So
that's
in
what
our
we want to demonstrate here.
so
Yeah.
in our case, it would be, let's say we have some recent writes from the last hour, right? And then this is something we want to update real time, but the writes from yesterday, they don't really change, right? So then for the writes from yesterday, we can use a data warehouse, but for the
Yes, you can use the data. Yeah, correct.
use
Yeah.
Ryzen, right? And so here the distinction would be whether we need to have recent data versus whether we analyze historical data, right?
Yeah,
More
correct.
super recent, like from yesterday, if we don't need this granularity, right? So then the not so recent data would go to data warehouse, ClickHouse in this case, while recent data will stay in RisingWave.
Yeah.
Okay.
Or you can further, yeah, correct. Yeah. Yeah, so continuing on, yeah, this is actually just showing you how you can sync data. So the patterns here is very similar to any sort of downstream sync. So not just ClickHouse, you can use other things. Yeah. So here the very first thing we'll do is to just create a table in ClickHouse actually. So let's just start the ClickHouse. Oops. Let's start the ClickHouse client. This. Yeah. So we've created a table in ClickHouse. And so this is where we will be syncing data to into this ClickHouse table here. And on RisingWave side, of course, you need to create something to connect from RisingWave to ClickHouse, right? So that's the sync. And so let me just go over that, like, how exactly do you configure that? Basically here, what we do is we just select the fields we are interested in, right? Average fair amount, number of writes per minute, and yeah, and then we specify connector and so on and so forth. Yeah. So we just run that in RisingWave. Oops. And yeah, the sync is created, right? So we can actually run just some simple queries in ClickHouse to show that, the data has been synced. And sorry, this multi-line. Let me just run the first one. Yeah, you can see that the data has been synced. Okay, it's maybe not updated so frequently. Yeah, but yeah, you can see that the data has been synced to ClickHouse. And yeah, I think that's
How does
about it.
this actually work? Because in this particular
Yeah,
query, if I understand correctly, if I remember this query correctly, so we truncate the second part and we do aggregations on the minute basis and we calculate we do some calculations. While
yeah,
this minute is still not finished, inside RisingWave, we will see numbers change, right? So for the current minute, all the writes that finished right now will influence the numbers we get? Does it mean that
Sorry.
RisingWave will wait till it stops updating and only then it will sync to ClickHouse, or it will override the data in ClickHouse?
Oh no, it will keep updating ClickHouse.
Okay.
Yeah. As the data gets processed, it would immediately update ClickHouse. Yeah.
Mhm. Why do we need
Sorry. So
to?
it didn't change it because, yeah, sorry.
Yeah, like can't we just say like we don't want to compute it right now? Let's wait for 10 minutes after the latest record was updated and only then sync, or is too
Oh,
complex.
10 minutes after the latest. You
No, I'm just saying,
probably,
like, let's say if we
hmm.
go back to our example where I said like for today we used RisingWave for crane data, and for yesterday when all the trips already finished, we use ClickHouse. So in this particular case, when the data no longer gets updated, so do we want to sync these specific records to ClickHouse, right? We would just
Oh, okay.
a
I mean,
different.
what you can do is, I mean, you can do a filter inside ClickHouse itself. So you can sync with a timestamp, right? So you can sync with a timestamp. Like maybe you include like the drop-off field or something, and then inside ClickHouse, you just filter it. Because I mean, the data still has to be ingested, right? So whether you do it today or tomorrow, you can just do it as soon as the data comes and just ingest it into ClickHouse. If not, you have to store it somewhere still. Yeah. If not, the record is lost. Yeah.
And then there
So you
is
can
an
just, yeah.
yeah, sorry. There is
Yeah.
an
Yeah.
interesting question, like where eventually at the end all the data is stored. Is it stored in Postgres, RisingWave, ClickHouse?
It can be stored in, so RisingWave stores the data. Like if you create a materialized view, like the reason why you can query it is because it's stored. So actually, if you start and stop the cluster again, you should still be able to see those records inside RisingWave. Yeah.
Okay. So it like Postgres uses some internal format for storing the data. RisingWave is doing
Yeah.
something similar.
Yes, it does have an object store. Yeah. So it does store the data there.
I remember at the beginning you showed us a diagram with object store.
Yep, yep.
Okay, you're almost done, right?
Yeah, so this is just a summary, of what you have learned. So yeah, ingest data, how to process it, how to sync the data from RisingWave to ClickHouse. And there's also a tutorial link here that I can share. You can go through the tutorial. And yeah, I think I can go over to the rest of my slides. Yeah, so we're done with the project demo. And so recently we have a new standalone mode, which basically runs RisingWave in a single process. So you can run that, if you want a lightweight RisingWave instance. Yeah, you can check out the website for more details. It's in the quick start part.
Compose, right?
Again?
You mean without using Docker, Docker Compose, all
Yeah,
that?
correct. Yeah. So you
Mhm.
can just like really install it. Yeah.
So it's like
And
similar,
then,
can install Postgres without Docker versus running
yes. Yeah,
Docker.
correct. Yeah. 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 So, I mean, with that, that's the end. I mean, I will still stick around for I think you still have 10 minutes, right? Yeah. So if there's any questions, feel free to ask.
Yeah,
We
there
can have
are.
more discussion. Yeah.
So I was taking note on of these questions, and the first
Yeah.
question is, what's the difference between RisingWave and Apache Flink? Like, because I know Apache Flink can also do all these joins,
Yeah.
right? So what is the main difference between these two, between RisingWave and Flink?
Okay. So I think there's a few things that come out on the top of my mind. I think first would probably be performance. We do some benchmarking for a Rising Wave. So we use this thing called Nix Mark. So actually across the board, I think our queries outperform Apache Flink, some by several times actually. And then, so that's one thing. The second thing to mention would be checkpoints, right? I think for Apache Flink, if your cluster goes down, it's quite common to wait like minutes like for it to come back, sometimes even longer, right? But for RisingWave, because we do this frequent checkpointing, yeah, our downtime is very short, like under a minute. Usually you should be able to recover already. Yeah. And so those two things. And besides that, I think things like creating materialized views on materialized views, I don't think you can do that on Apache Flink. You can correct me if I'm wrong, but the last I remembered is you have to sync the data out to some external system, sync it back again into Flink, because I don't think Flink has like some native storage. Yeah. Uh, yeah, so these three things come to mind. Yeah.
Last time I used Flink, I remember I needed to use Scala for that. I'm not sure because I know in Spark you can use SQL. I guess in Flink you can also use SQL, right? So with this regard, in RisingWave you can use SQL. In Flink you probably can use SQL. So the difference is more on the performance level rather than interface.
Mm-hmm. Yeah.
Like why did you decide to go with PostgreSQL compatible syntax and interface? Like
I think
other,
mhm.
like for example, Flink, like they don't do that because they have like their own Scala API, whatever. Yeah.
Well, I
So
think Postgres is like battle tested, right? And like it's what a lot of developers are familiar with and what they trust, right? So yeah, I mean a lot of tools out there are also PGWire compatible, right? As you can see during the workshop, we just use PSQL, really convenient.
mhm.
Um yeah, so we just want to leverage that. Yeah.
I'm just taking a look at the questions. I think we covered most of the questions. Mm.
Yeah. Actually, I can also run through the previous slides if like I think there was some oh, something was oops, something is closed.
Since we
Yeah, there
do
was some
cover. So you talked a lot about query plans. You showed us these things. We don't really cover that in course. We
yeah.
briefly touched that in the Spark section, in the Spark module when we talked about the execution plan.
Yeah.
But maybe you can suggest us some resources where people can learn more about that. Like, for example, how can we understand the output of explain in Postgres, right? Things like that as a starter.
Okay, for Postgres, I'm not so
But
familiar with
maybe
it, but I think it should be similar to RisingWave,
yeah.
like for the plan. Like it's also similarly structured and stuff. So, but how do you get around to understand the query plan? Is that what you're asking?
Yeah, exactly.
Yeah.
Well, for example, I had a database architecture classes
Yeah.
12 years ago. I vaguely remember something from those times. So for me, it
Yeah.
wasn't completely unrelatable. So I still
Yeah.
remember this. I don't remember the book we used, like this database book. But yeah, maybe there is a resource that you can recommend for people who can learn, who want to learn more about like execution plans, like how exactly is SQL queries translated to these building blocks, which are executed.
Okay. Well, personally, what I did is just, take these query plans and like draw them out. So I don't really know of any like really good resources to understand query plans. So what I generally do is, so you can see like stream filter, stream project, these names, right? Actually, these are quite common names like for plan nodes. So what I do is just search for their functionality, like just Google them to see
Mm-hmm.
like how exactly they work. I think the more complex parts would be like joins, right? Because we are talking about streaming systems, right? There's many, many different kinds of joins, not just hash join. So that's the more complicated part. Yeah,
Mm-hmm.
but besides that, I think most things, if you just look at the query plan itself, actually, it's not too complicated. Like, of course, there's a lot of noise, I would say. But if
Mm-hmm.
you just look on the left-hand side, for example, like if you just look at the names, right? Yeah. Sorry, am I sharing my screen? Are you able to see the
Presentation, the slides.
presentation slides? Am I on there?
Yeah.
Okay, yeah. So I mean, yeah. So this is a query plan, right? So if
But
you
I
just
see,
look at the names,
now I see. Thank you for joining the workshop and 3 QR codes.
oh, oops, that's not the wait. Okay, I think that should be. Does it update?
Yeah, yeah.
Okay, yeah. So yeah. So if you just look at like, the names itself, you can sort of guess what they're gonna do. And yeah, I mean, you just match them to different parts of your query, right? Like you'd have to think, okay, where does data come in? You're scanning from a table, that should be table scanned. Data is being filtered, that should be stream filter. Data is being projected. What does that mean? Well, you look inside the expressions, you can see that, there's a addition there. So you can match that to a part of your query as well. So yeah, basically just explaining all of the using explain. So using I didn't really demonstrate explain, but if you use explain, if you use explain on your queries, right? So we have several queries that we ran. Everything can be explained, even syncs actually. Um, right, explain, right? Everything has a plan that we execute. So if you just explain everything, you should be able to sort of understand it. If you want to see something like a trace of how the plan is being generated, you can use explain trace for it.
What is a trace?
So trace, okay, this goes into more of the internals of the system, but basically, your system will do some optimizations and stuff, and you'll generate a whole sequence of plans. Yeah.
Mhm.
So yeah, if you're more curious about the internals of it, how it's being formed, from your query, you can look at the trace as well. Yeah.
But I would
Um,
guess that, like, if you need help, if somebody wants to play, let's say, start with Postgres before moving to something more advanced,
yeah.
I'm pretty sure ChatGPT can explain many things. Like, you're gonna
Yeah.
tell, like, explain like I'm dumb, like what's happening.
Yes, yes. I think that will be helpful also. Yeah.
I actually never tried this sort of query. Like, usually I do explain like I'm 10 for concepts outside of computer science, but like
Yeah.
10-year-old kids usually do not have any exposure to database internals, so probably.
Oh, I'm sure you can do pattern recognition on like your query plan because it's sort of structured, it's like semi-structured.
Uh,
Yeah. So you might be able to recognize it.
yep. Okay, I think that's all right. I see
Yep.
somebody is good luck with the homework. Do you want to say a few words about the homework before we wrap up?
Oh
I
yeah,
think
I should definitely do that. Okay. Yeah.
because
So the
there's
for homework itself,
now a giveaway, right? So if I scroll up, I'm quoting Giovanna. We'll have little something for everyone who completes the homework. So
mhm.
yeah, we will add more details into the uh, in the repository.
Yeah.
But
So we add it like to the homework page. Yeah. Yeah. So a bit about the homework itself. So yeah, you can just set up the cluster and make sure to run question 0 just to make sure that your cluster is set up correctly. You can verify the results. We are running on static data here. So notice how we use seed Kafka instead of stream Kafka. So here we just use the historical data so we can check the answers. Yep. So yeah, question 0, question 1, question 3. Question 0 has the answer already. But for the rest of it, yeah, it should be pretty straightforward to do. Um, Yeah,
mm,
because they use patterns that we cover in the workshop. So feel
mm.
free to like ping me if you are not sure, if you need some hints as well. Or a hint that I can give is RisingWave is a batch system as well. So do what you will with that. Yeah.
And yeah, I will create a form. I have not created the form yet for submitting these questions. So I'll try to do this tonight and then I will share the link
Yeah.
and
Sounds
link
good.
in the homework MD file too. Apart
Mm-hmm.
from that, um, I don't have anything to add apart from thanking you, Noel, and everyone else for joining us today.
Yeah.
And
Thank
yeah,
you so much for organizing this, Alexei.
and everyone have fun now with RisingWave. this will be entertaining. I already can sense that. Yeah, so have fun with the homework and RisingWave.
Yep.
And hopefully you can also get a t-shirt like that. I don't know what's this little something, but this is a very convenient t-shirt. I really like it. Hey, well, I guess that's it. So yeah, see you soon.
Okay, see you all.
And
Bye.